Welcome to Raaonline Anatomy lecture series. Can you see a picture of a bird? Please do not rub your eyes to get a clear image of this. This is the image perceived by a person who is suffering from diplopia, that is double vision. Normally, when we see an object, the eyes are coordinated in such a way that we see a single image of the object. We perceive the image as a single image in our brain. But when there is small alignment of the eyes, we get two different images in the brain. This causes double vision. So to understand this disease and to treat this disease, we should understand the muscles which regulate the movement of the eyeball. So the undergraduate should be competent in describing and identifying the extraocular muscles of the eyeball, which are responsible for the movements of the eyeball, and the anatomical basis of the nerve palsies which are associated with these muscles. The extraocular muscles are also called as the extrinsic muscles of the eyeball. They are voluntary skeletal muscles. They are the levator palpebrae superioris, superior rectus, inferior rectus, medial rectus, lateral rectus, superior oblique, and inferior oblique. Among these, except levator palpebrae superioris, the other muscles, they regulate the movements of the eyeball. The levator palpebrae superioris, it elevates the upper eyelid. So we are going to concentrate on these muscles first and then the levator palpebrae superioris. The recti muscles take origin from a common tendinous ring or called as annulus of Zinn. This tendinous ring is attached here like this, enclosing the optic canal and the medial part of the superior orbital fissure. This ring is attached to a tubercle on the inferior margin of the superior orbital fissure, and above it is attached to the lesser wing of sphenoid. The recti muscles take origin from this annulus of Zinn. The recti muscles are named according to the part from which it is taking its origin. So, the medial rectus takes origin from the medial part of the ring, inferior rectus from the inferior part of the ring, the lateral rectus from the lateral part of the ring, and the superior rectus from the superior part of the ring. Each rectus muscle is enclosed in a fibroareolar sheath, and the margins of the sheath are connected with each other. This is musculoareolar cone, which forms a muscle cone. So the whole thing is a muscle cone. So the structures which are entering through the optic canal and the part of this superior orbital fissure within the muscle cone are present inside the muscle cone, and the other structures which are present in the lateral aspect of the superior orbital fissure and the inferior orbital fissure are outside the muscle cone. So you can see here these structures which are emerging through the optic canal and the part of the superior orbital fissure are inside the muscle cone. And in this image, you can see that the oculomotor nerve and the abducent nerve here. The abducent nerve are within the muscle cone, whereas the trochlear nerve is outside the muscle cone. The recti muscles, they run forward and they are inserted to the sclera in the anterior part of the eyeball, just posterior to the sclerocorneal margin, approximately 6 mm behind the sclerocorneal margin. So this is the insertion of the recti muscles. So they take origin from a common tendinous ring. They run forwards and they are inserted to the anterior part of the eyeball, just behind the sclerocorneal margin, approximately 6 mm from the sclerocorneal margin. Though we say it is 6 mm, these are the actual measurements of the insertions of the recti muscles. So when you trace the origin of the recti muscle from the medial rectus to the superior rectus, it traces a spiral line. This is called a spiral of Tillax. This is important during the surgeries of eyeball. The superior oblique muscle, it takes origin from the body of the sphenoid bone Here it's body of sphenoid bone, supromedial to the optic canal, outside the tendinous ring. So this is the origin of superior oblique muscle. And here you can see the superior oblique muscle taking origin from the body of sphenoid, supromedial to the optic canal, and it runs upwards and forwards and it becomes tendinous, and this tendon passes through a fibrocartilaginous pulley which is present over the trochlear fossa in the medial part of the roof of the orbit. So there is a trochlea, fibrocartilaginous pulley which is present on the medial part of the roof of the orbit. And here the tendon changes its direction, then it runs in this direction, inferiorly, posteriorly, and then it is inserted to the suprolateral quadrant of the eyeball behind the equator. So remember, all the recti muscles are inserted into the sclera in the anterior half of the eyeball, that is in front of the equator. Equator is an imaginary line which separates the eyeball into two equal halves, anterior and posterior halves. So recti muscles are inserted anterior to the equator, in front of the equator, whereas the oblique muscles are inserted behind the equator. Superior oblique is inserted to the suprolateral quadrant of the eyeball behind the equator.